There is a specific, terrified silence that occurs inside the troop compartment of an amphibious assault vehicle when the engine pitch changes in the open ocean. For the United States Marines who have ridden the AAV-7 into the surf for more than 4 decades, that sound is the soundtrack of a very particular nightmare. Imagine sitting in total darkness, crammed shoulder to shoulder with 18 other fully equipped infantrymen, smelling the thick mixture of diesel fumes, hydraulic fluid, and seasickness, while 26 tons of aluminum bobs in the Pacific Ocean like a cork. You are trusting a design from the late 1960s to defy physics. You are trusting a vehicle that is essentially a watertight tank to swim through rough seas, knowing that if the seals fail or if a track slips, you are not in a boat. You are in a 26-ton anvil that will sink to the bottom before you can unlatch the heavy overhead cargo hatches. For 40 years, this machine has been the backbone of the Marine Corps' ability to project power from the sea. It is the AAV-7, often called the Amtrac, or simply the track, and it represents one of the most difficult engineering compromises in the history of military technology. It was built to solve a problem that no other nation tackled with such aggression: how to move a platoon of Marines from a ship located miles offshore through the punishing surf zone across a sandy beach, and then drive them inland to fight like a mechanized infantry fighting vehicle. It is a machine asked to be a boat, a tank, and a bus all at once, and in trying to be all three, it became a master of none and a terrifying ride for everyone involved. The central conflict of the AAV-7 is not just about its age, although it is ancient by military standards. The conflict lies in the fact that the very requirements that defined its existence, lightweight armor for buoyancy and a flat-bottomed hull for hydrodynamics, made it catastrophically vulnerable to the threats of the modern battlefield, specifically improvised explosive devices and anti-tank guided missiles. Yet the Marine Corps kept it in service, upgrading it, patching it, and pushing it into combat long past its expiration date. Why did they keep a vehicle that earned the grim nickname the tuna boat and, tragically, the Iron Coffin? To understand that, we have to peel back the layers of amphibious doctrine, engineering limitations, and the sheer stubbornness of the Marine Corps ethos. If detailed technical breakdowns of military design and strategy interest you, subscribe. I have got more of these coming. To understand the AAV-7, you must understand the shadow of the Second World War. During the Pacific Campaign at places like Tarawa and Iwo Jima, the Marines learned in blood that seizing a beachhead was the most dangerous military operation known to man. They developed the LVT, the Landing Vehicle Tract, the grandfather of the modern Amtrac. These early vehicles were slow, unarmored, and barely seaworthy, but they could cross coral reefs that stopped traditional boats. As the Cold War heated up, the doctrine evolved. The Marines needed to launch from further out at sea to protect the fleet from nuclear strikes or coastal missile batteries. This meant the vehicle needed better seakeeping capabilities and more speed. It also needed to be fully enclosed to protect the troops from nuclear fallout and chemical weapons. In the late 1960s, the FMC Corporation developed the LVTP-7, which would later be renamed the AAV-7. The design philosophy was dictated by the laws of buoyancy. To make a 20-something ton vehicle float, you have to displace a massive amount of water. This dictates a large, boxy shape, a literal shoebox on tracks. But weight is the enemy of flotation. Steel, the standard material for armored fighting vehicles, was simply too heavy for the size of the vehicle they needed. So the engineers made a decision that would haunt the vehicle for its entire service life. They built the hull out of 5083 aluminum alloy. Aluminum is light. It allowed the engineers to build a large hull that could carry 21 combat-loaded Marines plus a crew of 3 and still float with a reasonable freeboard. But aluminum has different ballistic properties than steel. It is softer. To get the same protection level as steel, you need much thicker plates, which negates some of the weight savings. Furthermore, when aluminum is hit by high-velocity shaped charges, like those from a rocket-propelled grenade, it behaves differently. There is a phenomenon known as spalling, where the interior of the armor flakes off and turns into shrapnel, blending with the molten jet of the warhead. And perhaps most disturbingly for the crews, aluminum has a lower melting point than steel and can burn intensely under specific catastrophic conditions, contributing to the vehicle's vulnerability to fire. The hull of the AAV-7 measures nearly 8 meters long and over 3 meters wide. It is a massive target. The front of the vehicle features a large, hydraulically operated bowplane. When on land, this plate folds flat against the nose, adding a layer of spaced armor. But when the vehicle enters the water, the driver extends the bowplane forward. This is critical for hydrodynamics. It stops the nose from burying itself in the waves and creates a planing surface, allowing the vehicle to move more efficiently through the water. However, this mechanism is complex. It involves heavy hydraulic rams and hinges, all of which are subjected to the corrosive brutality of saltwater and the physical battering of crashing through surf. If the bowplane fails to extend, the vehicle risks swamping. If it fails to retract on the beach, it blocks the driver's vision and impedes mobility. Let us look at the propulsion, because this is where the split personality of the AAV-7 becomes technically fascinating. On land, it drives like a tank. It uses a torsion bar suspension system with 6 double-tired road wheels on each side. The tracks are steel with removable rubber pads to save the roadway and provide grip. But when it enters the water, the tracks alone are not enough. While the tracks do rotate in the water, providing a small amount of propulsion, they are inefficient paddles. To achieve the required water speed of roughly 13 kilometers per hour, the AAV-7 engages 2 large water jet pumps located at the rear of the hull. These water jets are driven by the main engine through a power takeoff shaft. They suck water in from intakes on the bottom of the hull and blast it out the back. To steer in the water, the driver uses the same steering yoke as on land, but instead of braking the tracks, the input deflects the nozzles of the water jets. It is a clever integration, allowing a seamless transition from land to sea. The driver does not need to stop to switch modes. They simply engage the jets and drive into the surf. But this integration comes at a price. The drivetrain is incredibly complex. The engine has to power a transmission that drives the tracks and the water jets, sometimes simultaneously, during the transition phase. This places immense strain on the power plant. Originally, the vehicle was powered by a Detroit diesel 8V53T engine, a 2-stroke monster that was loud, smoky, and leaked oil as a matter of routine. However, the demands of modern combat gear, additional armor, and the need for speed led to a major upgrade program. The current iteration, the AAV-7A1, is typically powered by a Cummins VT400, a 4-cycle, turbocharged V8 diesel engine producing roughly 400 to 500 horsepower, depending on the tune and the specific variant. This engine is mounted in the center forward part of the hull, right next to the driver and commander. The noise is deafening. There is no sound insulation to speak of. The heat from the engine radiates directly into the crew compartment. For the Marines sitting in the back, the engine is a roaring, heat-spewing beast that separates them from the crew up front. On the far right front sits the troop, on the far right front sits the troop commander or a gunner. The 21 infantrymen are packed into the rear compartment on 3 bench seats, one running down the center and one along each wall. It is a claustrophobic, rattling metal box. The only way out is through the massive rear ramp, which is hydraulically operated. This ramp is the vehicle's mouth. It drops down to allow troops to sprint out onto the beach. But in the water, that ramp must be sealed tight. The seals are rubber. Rubber degrades. Salt water corrodes metal sealing surfaces. The constant flexing of the hull as the vehicle drives over rough terrain can warp the door frame. Consequently, AAV-7s leak. They always leak. Every vehicle is equipped with high-capacity bilge pumps designed to evacuate water faster than it can come in. The crew's life depends on those pumps. If the electrical system fails, or if the pumps clog with debris, which happens often in the chaotic environment of a troop carrier, the vehicle fills with water rapidly. In the early 1980s, the Marine Corps realized that the original armament of the AAV-7 was laughably inadequate. It carried a single M85 machine gun, a .50 caliber weapon that was notoriously unreliable. It was often said that the M85 was more dangerous to the operator than the enemy because of its complex receiver and tendency to jam. To fix this, the Marines introduced the Upgunned Weapon Station, or UGWS. This was a new turret that brought a serious increase in firepower. It paired the reliable M2 heavy barrel .50 caliber machine gun with the Mark 1940 mm automatic grenade launcher. The Mark 19 is a beast of a weapon. It fires high-velocity grenades out to a range of 1,500 meters or more. It can suppress a tree line, destroy light vehicles, and provide devastating area fire. Having this weapon mounted on the AAV-7 transformed it from a mere taxi into a fire support vehicle. The turret is electric hydraulic, allowing for relatively fast traverse, but it is not stabilized. This is a crucial distinction. Modern infantry fighting vehicles like the Bradley or the Leopard 2 have stabilized guns, meaning the computer keeps the gun on target even while the vehicle is bouncing over rough terrain. The AAV-7 does not. To fire accurately, the vehicle usually has to stop. In the water, firing accurately is almost impossible due to the wave motion. The Upgunned Weapon Station gave the vehicle teeth, but it also added weight to the top of the vehicle, raising the center of gravity. This exacerbated the vehicle's tendency to roll in rough seas and made it more unstable on side slopes on land. It was the classic armored vehicle trade-off: more lethality equals more weight, which compromises mobility and stability. The engineers had to constantly fight this equation. As the years went on, the weight kept climbing. The Marines added bolt-on armor kits known as EAAK, Enhanced Applique Armor Kits. These are the corrugated, wave-shaped panels you often see on the sides of the AAV-7s in photos from the Iraq War. They are designed to disrupt the shaped charge jet of an RPG and provide better protection against heavy machine gun fire. They work, but they are heavy. The vehicle, originally designed to weigh around 23 tons, ballooned up to nearly 29 tons fully loaded. The suspension groaned under the load. The engine struggled. The ground pressure increased, meaning the vehicle was more likely to get bogged down in soft mud, ironic for an amphibious vehicle. This led to the most significant overhaul in the vehicle's history: the RAM/RS program, which stands for Reliability, Availability, Maintainability/Rebuild to Standard. Initiated in the late 1990s, this program essentially gutted the AAV-7. They kept the hull, but they replaced the entire suspension system with components derived from the U.S. Army's Bradley fighting vehicle. The Bradley suspension is robust. It uses stronger torsion bars and better shock absorbers. They also installed the more powerful Cummins engine I mentioned earlier. The RAM/RS upgrade gave the AAV-7 a new lease on life. It could handle the extra weight of the armor. It had more power to climb out of mud. It was faster on land, capable of reaching speeds of 70 kilometers per hour on hard surfaces, terrifyingly fast for a box of that size. However, the RAM/RS upgrade introduced a subtle but deadly flaw. The Bradley suspension components were heavier and sat differently on the hull. This changed the vehicle's center of gravity and its buoyancy characteristics. In the water, the RAM/RS vehicles sat lower. The freeboard, the distance from the waterline to the top of the hull, was reduced. This meant that in rough seas it was easier for waves to wash over the top or into the intake and exhaust ports. The margin of error for the crew was sliced thinner. The vehicle became less forgiving of mistakes or mechanical failures in the water. This technical reality crashes head-on into the operational history of the vehicle. The AAV-7 was designed for a World War III scenario, storming the beaches of the Soviet Union or its allies. But where did it see its most intense combat? In the deserts of the Middle East. In 1991, during Operation Desert Storm, the AAV-7s led the charge into Kuwait. At the Battle of Khafji, Marines fought from their tracks against Iraqi armor. The AAV-7, designed to float, was used as a desert tank. It performed surprisingly well in terms of mobility, crossing the sand berms and salt flats. But the vulnerability of the aluminum hull was exposed. Iraqi artillery and tank fire could slice through the AAV-7 like butter. The crews knew it. They packed sandbags on the floors to protect against mines. They strapped extra gear on the outside to act as makeshift armor. Then came the invasion of Iraq in 2003. This was the AAV-7's defining moment and its greatest trial. 1st Marine Division drove these amphibious tractors all the way from the Kuwaiti border to Baghdad. This was never the plan. The doctrine said the AAV-7 drives you from the beach to the secure inland area, and then you get out. It was not designed for a 500-kilometer road march into the heart of an urban combat zone. But the Marines had no other choice. They needed the mobility and the heavy firepower of the Mark 19 grenade launchers. The drive to Baghdad highlighted the grim reality of the Iron Coffin. In the ambush alley of Nasiriyah, AAV-7s were hammered by RPGs and heavy machine gun fire. This is where the tragedy of the aluminum hull became visceral. When an RPG hits a steel tank, it might penetrate, but the steel holds its structure. When an RPG hits an aluminum AAV-7, the catastrophic failure can be total. There were incidents where vehicles were penetrated, the fuel cells ignited, and the ammunition cooked off, resulting in the total loss of the squad inside. The vertical sides of the hull, designed for efficient stowage and hydrodynamics, are ballistic nightmares. They present a flat surface at a 90-degree angle to incoming fire, maximizing the penetrator's effectiveness. Marines adapted. They started riding on top of the vehicles rather than inside. It seemed counterintuitive, exposing yourself to sniper fire, but the logic was grim. If the vehicle hits a massive IED or takes an RPG hit that ignites the fuel, you have a chance to be blown clear or jump off. If you are locked inside the troop compartment, you burn. The top cover strategy became standard procedure. The urban environment of Iraq also exposed the visibility problems. The driver looks through small periscopes called vision blocks. His field of view is extremely limited. He cannot see a child running in front of the tracks or a sheer drop-off to the side. The vehicle commander has a better view from the turret, but he is focused on scanning for threats. Maneuvering a vehicle that is 3 meters wide through ancient narrow streets designed for donkey carts was a harrowing experience. The AAV-7s crushed cars, knocked down walls, and tore up pavement. They were bulls in a china shop, but they delivered the Marines to the fight. Knowing what you now know about its performance in the field, do you think the design trade-offs were worth it? Share your thoughts below. The maintenance burden during these operations was crushing. The tracks, designed for sand and surf, were being chewed up by asphalt and concrete. The rubber pads wore out in days. The engines, sucking in the fine talcum powder dust of Iraq, required constant filter changes. The bilge pumps, critical for water operations, would get clogged with sand and trash. Marine mechanics worked miracles, often cannibalizing parts from damaged vehicles to keep the column moving. The Ram/RS upgrade proved its worth here. The older suspension would likely have snapped under the strain of the march to Baghdad. but the wear and tear on the fleet was permanent. These vehicles, built in the 70s and 80s, were being aged decades in the span of a few months. This brings us to the agonizing saga of replacing the AAV-7. Why, if it was so vulnerable and old, did the Marines keep it? The answer lies in a failed dream called the Expeditionary Fighting Vehicle, or EFV. For 2 decades, the Marine Corps poured billions of dollars into developing the EFV. It was supposed to be the Ferrari of amphibious vehicles. It was designed to plane across the water at nearly 30 knots, 3 times the speed of the AAV-7. This would allow the Navy ships to stay 25 miles offshore, well out of range of enemy missiles, while the Marines zoomed to the beach. To achieve this, the EFV had a complex retractable suspension, a massive 3,000 horsepower engine, and foldable flaps to create a planing hull. It was an engineering marvel. It was also an engineering disaster. The complexity was off the charts. It was unreliable, incredibly expensive, and provided poor protection against IEDs because the flat bottom needed for planing is the worst possible shape for deflecting a blast from below. In 2011, after burning through $3 billion, the program was canceled. The Marines were back to square one. They had bet everything on the EFV and lost. The AAV-7, the old warhorse, had to soldier on. This failure forced a doctrinal shift. The Marines accepted that high-speed water skimming was technically and financially unfeasible. They pivoted to the Amphibious Combat Vehicle, or ACV. The ACV is fundamentally different. It is an 8x8 wheeled vehicle, not a tracked one. It swims but slowly, like the AAV-7. It relies on ship-to-shore connectors, like hovercraft, to bring it closer to the beach if the ships need to stay far out. But once on land, the wheels offer better speed and mobility on roads. Crucially, the ACV has a V-shaped hull. This is the lesson learned from the IED wars. The V-shape deflects the blast energy of a mine away from the hull, protecting the crew. The transition to the ACV is currently underway, but it is slow, and until it is complete, the AAV-7 remains in service. But its operational envelope has been severely restricted. Following the tragic sinking off San Clemente Island in July 2020, where 8 Marines and 1 sailor drowned, the Marine Corps made the difficult decision to ban the AAV-7 from scheduled waterborne deployments. The investigation revealed a cascade of failures, leaky seals, missing drain plugs, insufficient training, and a mechanical breakdown in rough seas. It was a stark reminder that no amount of upgrades can change the fundamental physics of a 40-year-old design. The vehicle had simply become too dangerous to use for its primary purpose in peacetime training. The AAV-7 is now a landlocked beast for the most part, used for mechanization and gunnery, but its days of storming the surf are effectively over. This marks the end of an era. For 2 generations of Marines, the smell of diesel and the lurching motion of the track were the definition of their service. When we assess the legacy of the AAV-7, we have to look past the death trap headlines. Yes, it was flawed. Yes, the aluminum hull was a liability in modern combat. Yes, it was noisy, uncomfortable, and mechanically temperamental. But we must also acknowledge what it achieved. It provided the U.S. Marine Corps with a capability that no other military possessed. No other nation could put a battalion of infantry onto a hostile beach and then drive them hundreds of kilometers inland with their own organic armor support. The Soviet equivalents, like the BTR series or the BMP, could swim, but only in calm rivers or lakes. They would sink instantly in the ocean surf that the AAV-7 tackled routinely. The AAV-7 allowed the Marines to threaten any coastline in the world. That strategic ambiguity forced adversaries to defend everywhere, tying up resources. The engineering of the water jets and the transition from land to sea, while complex, was a triumph of 1960s ingenuity. The vehicle bridged the gap between the naval architect and the tank designer. It proved that you could make a 26-ton box swim even if it wasn't pretty. However, the so what of the AAV-7 story is a lesson in the dangers of requirements creep and sunk cost fallacies. The Marines held on to the requirement for a vehicle that could do everything: swim fast, fight hard, and carry a lot of troops. By trying to hold on to that impossible triad, they delayed the replacement for too long. They forced a Cold War relic to fight in counterinsurgency wars it was never designed for. The cost was paid in maintenance hours, in tactical limitations, and ultimately in the lives of the crews. The AAV-7 is a testament to the bravery of the tracker community. These Marines loved and hated their vehicles with equal passion. They knew the quirks of every hydraulic pump and the specific rattle that meant a track pin was backing out. They drove them into the ocean at night, into the sandstorms of Kuwait, and into the narrow streets of Fallujah. They made a flawed machine work through sheer force of will and competence. As the amphibious combat vehicle takes the reins, it brings better armor, modern electronics, and a safer hull design. But it will likely never match the sheer brute force versatility of the AAV-7. The old tracker is a dinosaur, yes, but it was a T-Rex. It was a predator that dominated its specific ecological niche for nearly half a century. We are watching the extinction of a specific type of warfare. The idea of storming a defended beach with waves of slow-moving armored vehicles is likely gone, rendered obsolete by long-range precision missiles and drones. The AAV-7 was the king of that tactic. Its retirement is not just the end of a vehicle, it is the closing of a chapter on the age of the massive amphibious assault. The AAV-7 will eventually be melted down or parked in museums. Visitors will look at its boxy shape, its massive tracks, and the weird water jets on the back, and they might wonder how anyone had the courage to drive it into the ocean. But for the Marines who served in it, the memory will be visceral. The smell of the grease, the roar of the Detroit diesel or Cummins engine, and the feeling of the tracks biting into the sand as they clawed their way out of the surf and onto the beachhead. It was an amphibious nightmare, perhaps, but it was their nightmare, and it carried them into history. If you found this analysis useful, a like helps more people discover these deep dives. Thanks for watching.